Good afternoon to you all. Thank you very much for joining us on this second afternoon of the European Conference for Research, for results from research projects. We will be listening on this session, which is called Crash Protection and Collision Avoidance. I am your moderator for this session. My name is Anka Pashka, and I'm a project advisor working in CINEA. My portfolio is on road safety and also on mission cities. I will be co-moderating this session with Peter Orban from RWTH ICA in Germany. And we will listen from 3 projects that are all in different stages of implementation. Hello, don't hesitate to come in the front. We still have some seats. Yes, well, like you all know, in this session, we will discuss the need for avoiding the accidents, and when an accident cannot be avoided, on how can technology assist us to protect at best the occupants of the vehicle and those involved in an accident. Like you also know as well, despite recent developments and the improvements in road safety in general, the road accidents and their consequences remain a serious concern for the society. And on average, every year, some 70 people lose their lives a day in an accident, and over 370 are seriously injured. Half of this are car occupants. So we will see how the research projects funded by Horizon Europe try to improve these numbers, and how they approach these issues and which are their solutions proposed. So without further ado, I would like to introduce the 3 speakers from the projects that will be presenting today. So we will have the project SALIENT, V for Safety, and SafeUp. And the first speaker will be Raquel Ledo, which is presenting the project SALIENT. She's coming from Spain, from CITAG, which is the Automotive Technology Center of Galicia. Raquel has an extensive experience with the automotive industry, involved in different areas, but also as a researcher on European projects and various projects as such. And I would like to invite her to take the floor.
For your nice words, and thank you for your presence here today. SALIENT is a project, a funded project by the European Commission, obviously, that is focused on improve the safety of the occupants when a crash occurs. And we would like to improve this safety from the point of view of the structure of the vehicle, to improve the structure of the vehicle. So I'm going to explain how. Okay, SALIENT is just now in the mid of the project. We start in 2022 in September. So in 2 weeks we will have the midterm review. So some works have been already done, and others will be in the next half a year. CITAG is the coordinator. I work at CITAG, Technology Automotive Center of Galicia, and we count with the support of University of Northumbria for the technical coordination. We are 12 partners from 7 different countries, and there are, I think, a good mix between university research centers and industrial companies. So we can say 6 research entities: CITAG, CIDAUT from Spain also, IDIADA from Spain also, Fraunhofer, Virtual Vehicle, and the University of Northumbria. focus on the development and characterization of materials, the design of a new structure, and the virtual validation. Then we have the entities, the private entities, Tier 1 and OEM, that is IPG, Thermopre, and CREF Stellantis, that help us to identify what are the requirements of the automotive sector and to produce and manufacture the prototypes. And finally, two other entities, I forgot ASAS, it's also important for aluminium, and also two companies, VAX and Etelatar, who help us for dissemination, communication, and exploitation. So with a budget about 4 million euros, this is what we can do in this project. Well, the big goal, the big objective I mentioned before is to improve the safety of the occupants when a crash occurs. It's not able to avoid all crash, so we have to be prepared for when a crash appears. So this is the big goal, but we have other 3 points that we think that are also important. So the safety has a cost in terms of materials, in terms of money, in terms of different materials and processes we need. But we can't forget that automotive sector is very sensitive to the cost. So we have to keep in mind. That we should be sure that the circularity is assured in terms of that the consumption of energy, the consumption of materials, the reduction of waste. We have to think in all these points. Here we have some numbers that are the technical objectives, the quantitative objectives we have in this project. So we think that we have to think also in the weight reduction. I mean, the safety of the passengers should be better, but we have to reduce the weight of the car. So we are working about one reduction of 42% more or less in the front-end strata. I will explain later, but the focus, the scope of this project is the front end of the vehicle. And I talk about safety. Safety is the big question, is the big goal in this project. So when we talk about safety, we talk about we have to improve the correlation between the simulation and the real test, the physical test. So if we are able to improve this point, the final results in the real cars, in the cars in our streets, will be better. And other important point is related that currently the standards, the Euro NCAP and other homologation standards, covers a number of different scenarios or different crashes, but now these scenarios are changing. So we have to be prepared for this. So I mentioned, but I repeat, the goal of this project, the scope of this project is the front end of a car. We have chosen the front end because it's the more important subsystem in the car when we are talking about a frontal crash, and these frontal crash are the worst when we talk about injuries and fatalities. And I repeat, we have to keep in mind the lightweighting, the safety, and the circularity. This is, with a very brief summary, obviously, the approach we are tackling in Salient. So we are dealing with new materials, not new materials, but including some innovations. Then we have to talk also about the manufacturing processes. All these parts, materials, behavior material, processes, and so on, we need to simulate. We have to be sure that they are working at virtual level, we can say. Then I talked before about different scenarios. When I talk about different scenarios, I mean that some years ago, the differences between cars in terms of size, weight, was not so high as now it is. So today, and with the electric vehicle more so on, the different weights, the different size, the different heights in the cars are really high. And obviously, when a crash occurs, the impact is really different from a little car from 1,000 kilos than an electric sub from 2,000 kilos. So we have to think in these different scenarios, and we have to think also in the different angles of these crashes, because as all of you know, the behavior of the car is really good when the crash is in 90 degrees and just in the middle of the car. But if we goes to the sides, or we goes in different angles that not 90 grades, the behavior is really different. So the impact in the occupants is really different. So we have to be all these points in our minds to work on them. And obviously, at the end, we have to be sure that our new subsystem, our new front end, is meeting all the requirements in terms of crashworthiness. So, materials. What are we doing in Salient with materials? Well, I think that most of you agree with me if we talk that the best solutions at this moment are multi-material solutions. There are not one magical material. Well, maybe if we talk about graphene or something like this, but I repeat, we are in the automotive sector, so the cost is important. The cost effectiveness is a key factor. So multi-material for us is the good solution. In this case, we have chosen two materials. One case is the aluminum, because if we talk about lightweight reduction and we talk about cost effectiveness, we think that aluminum is the best option, or unless one of the best options. And then we are going also to work with thermoplastics reinforced with carbon fiber. You can say, okay, you are always talking about money, but carbon fiber is not in this way, and it's true. But we are talking about tapes. That means that we are only use these tapes, thermoplastic with carbon fiber reinforcement tapes in some places to reinforce. So at the end, the quantity of carbon fiber is not so high. So it's a good option. This was in terms of materials. If we talk about what is the approach we are using, okay, we are proposing an eco-design strategy. What I mean when I talk about eco-design strategy, okay. Well, first of all, we have to keep in mind the constraints we have in all development, in all projects. So we have to be sure that the designs and the design we are proposing will be manufacturability. We have to be sure that this design is able to go to the production line, and obviously, if we have to improve the safety of the passengers, we have to meet the crashworthiness requirements. This is mandatory, we can say. And then when we talk about eco-design, we talk about that when we are designing a new part, a new component, we are not thinking only in the behavior of this component. We have to think also in what is the environmental impact of this part, what is the environmental impact of the process we are using, how is the solution I have to develop for the end of the life of the vehicle when I need to recover some part. It's possible to reuse or not, or recycle or not. So we have defined 5 points. You can see there, recyclability, the capacity of assembly, disassembly, the integration we can achieve, that is, if we can go from 4 or 5 different parts to only one part, and the compatibility with the assembly line. And obviously lightweight, because it's one of my objectives. So this is my inputs. Then we obtain the first design and the first bill of materials, we can say, and we go through the CINEA analysis. Here we test the subsystem, front-end structure, I remind, but we test also the full behavior of the car. If we meet the results, all is okay, but as you know, at the first time is impossible or very, very difficult. So we have to come back to redesign, and we have to iterate 1, 2, 3 times we need to obtain a final design that meets with all these requirements. What is the way that we choose the first design? I'm sorry, I don't know if the numbers are visible for you, but the important are not the numbers, the important are the strategy we are using. We have to decide in some way what are the materials and what are the design we are going to use. So we define our we can say it, decision matrix, for example. As I explained before, the 5 points we have here, there are points that we have decided. We have decided according the requirements of the Tier 1 and of the OEM presence in the consortium, but also with the requirements that automotive sector have in general. So for us, I repeat the points: weight saving, recyclability, capacity of assembly, disassembly, capacity of integration of different parts, and compatibility with the assembly line. And we put different weight to each of these topics, these points. The weight of each point can vary, can be different, yes. It only depends of the strategy of the final OEM, of the preferences. Maybe, I'm not sure, but maybe Volvo has not so high requirements for lightweighting as Stellantis. I'm not sure, but it could be one also. So this is the decision matrix, and in this case we are comparing steel with aluminum, full aluminum, and 2 different mix of aluminum and thermoplastic reinforced with carbon fiber, design 3 and 4. At this moment, we are in, I told before, we are in the midterm of the project. So we have a first design, and we have obtained 52% of lightweighting. This is not real. I mean, it's real. We have achieved, but it's true that maybe this quantity at the end will be lower, maybe 48, 50%, because we have to adjust some design to be sure that absolutely all scenarios of different crashworthiness are being met. And until now, I have only talked about 5 minutes. Okay, I have only talked about materials and design. That is the standard in our industry, we can say. But we have to talk about 3 different technologies that we want to introduce to be sure that the behavior, the final behavior, is better. In this case, we are talking about shape memory alloys, active tapes, and inflammable, I think in French is gonflable, I don't know, ABS. All these technologies are related with the question I mentioned before. The best behavior of the car is when the crash is just in the middle and in 90 degrees. So it's the best option. So if the angle is different or the position of the crash is different, when these different 3 technologies, I will try to convert this not center crash and different angle crash in one center crash. I'm not sure if I'm explaining well, because it's not very obvious, and maybe in English it's not so easy. But the idea is for example, for the case AC3, to have several areas that with the capability to be deformed, and this capability and this deformation will occur with AD system advise us about the crash is imminent. So we receive this trigger, we can say, and this aluminum changes I don't have the word to avoid that occurs in an angle that is not the best one. And the same for the other. The AC1 will be focused on the crash box. The crash box will be made with the tapes. So with a trigger, maybe, we are not sure at this moment, maybe it will be a trigger of temperature or another type. We can change the rigidity of this part, so the way that the energy pass will be changing, so we can improve. And similar to the case of AC2 with active tapes, that we will be able to modify or to move the quantity of energy that is going through the straps. So this is the idea for the next 18 months with a design frozen, we can say, and now we are devoted to develop these systems. If we talk in terms of collaboration with other projects, until now we have collaborated with ELCA, European Lightweight Cluster Alliance. Also, we're EnLight Cluster, ALMA, Fatigue for Light, Revolution, Flamingo Flex Cars, and also Amulet. All of them are projects funded by the European Commission and working on this line of projects concerning lightweight, better safety, etc. And if we talk about the impact, well, it's difficult at this moment. We need one year more to be sure that our developments go for a real impact. But here you can see the summary of our expectations in terms of improve the safety, the lightweight, and the circular approach. You have more information in the website of the project, Salient project, and we have also LinkedIn or other social media to contact us, or to my email that is raquelledo@ctag.com. I think it's the time out, so...
Yes, thank you very much, Raquel. I would like to give now the floor to our next speaker. So it's Ciuca Kalisvat, who's coming from the Netherlands. Ciuca is working at the TNO Integrated Vehicle Safety, and he will present us the approach taken in the project V for Safety.
Good afternoon, everybody. Let me move this up. Yep. So good afternoon. I'll introduce you to V for Safety project, which is almost at midterm now, and so we are in the 16th month. It's a consortium of 17 partners. We have a funding of about 4.2 million, and we started in October 22. So I'm happy to show you the first results today. Essentially, the scope of V for Safety is on avoiding accidents. So we have special interest in vulnerable road users, and we think of safety measures that could make them more safe on the road. And with safety measures, we talk about technology, for example, a change in the car, a better person A, B, but it can also be a change in the road layout, or it can be a change in policy or regulation for a certain city or a certain crossing. So in that sense, we're taking a wide scope, and so we have the safety measures in all possible forms. Of course, you can have an opinion about this, and as we bring in experts and talk about this for a long time. We do talk about this a long time, but we also involve models. We want to have some repeatable, reproducible assessment. So indeed, we use models, simulation models. So you can imagine if we look at future solutions that are a measure to improve safety with pedestrians or cyclists or e-scooters, then modeling that is quite a sensitive thing, because simulation in itself is hard to repeat across organizations and get the same outcome. And it will be even harder if we talk about future safety measures. So that's, of course, then a major focus of V4Safety, to make simulations and simulation environment, simulation outcomes more comparable across organizations. Further two topics are, we want to project over time. So how does this safety solution and this simulation setup work if we think 10 years ahead, or if we translate from Germany to France, or to Italy, or to Galicia. So that's projecting across time and the region. Now, I did not start the clock yet, so now I did. So our objectives are, first of all, to create an assessment framework, predictive, so looking into the future and future solutions, for using simulation for road safety. That's our first objective. And actually we want to feed this into standardization. There is a peers network and an ISO working group that already has a standard out. But for future standards in that working group we are working. And eventually this should lead into the VMAT working group of UNEC. The second one is to give guidelines on how to work with all these models and describe the behavior of drivers, vehicle occupants, etc. in a consistent way. Then a methodology that helps to show you what you compare to, what is the baseline. So this, our goal is to have this approach being used, this method being used by 3/4 of prospective studies. I'll get into details on that. Then guidelines on how to use the models and the safety solutions. So how to use your simulation tools in such a way, set them up that you can have comparable outcomes if multiple partners work on this. Finally, we will demonstrate this with quite a number of use cases, and we work with the sister projects Phoebe and Soteria to share some experience, but also share a use case. And the projection I already mentioned. Good. We're in year 1 now, and we have quite a few results. So first of all, the draft prospective safety assessment framework is there. We discussed it with our advisory boards in January, and it will be sent out for them for detailed review in the coming weeks. We expect it to be available on our website in the coming months. So you can have a look and tell us what is missing, what you like, and whether it's useful for your application at all. This also contains some work on definitions. We do not want to reinvent the wheel because there is so many projects that work on definitions already or have work on that. We align with the Sunrise project on this to use the same, and we are also in touch with the FAME work on definitions and glossary. So the draft framework is now 106 pages, so it's already some substance to read. Then there's the human in simulation, That's quite an extensive model. I would say this is really the interface between human factors work and vehicle technology work, because you represent the human behavior in a dangerous scenario with a driver model. And that driver model tells you, okay, the human will react to this situation in this way. Of course, building driver models is an art in itself. So it's not simple. I'll show you an example in a minute. We look at driver response models to normal driving, but also if something scary is happening. So there might be also driver models nearing a possible accident. And so those kind of models are really important. These include also the well-established body models for in-crash simulation. So it's in itself, the project will create a couple of models itself, but mostly we will point to existing models because there's a lot out of there. So the literature study, let me see. Well, I know it's quite elaborate, but this is due much later in the project. We have an internal milestone to this year on the models in a couple of months. Then modeling the baseline. I already mentioned this. What do I compare to? So if I want to compare an adapted pedestrian crossing in 10 years, I want to compare it to the pedestrian crossing now, and look at what's happening there, what kind of accidents happen there, what's the normal driving behavior in a completely unrisky situation. So I need to represent that normal driving or that today's driving in some way. And there are several approaches of doing that, and we handle them in detail. In the ISO standard that I mentioned, there is already some material on that. It's ISO 21934. But in this case, we elaborated to make it more practical, because for all these baselines, you also need a lot of data. That's typically the bottleneck. Where do I find the data that actually describe pedestrian crossings? And is that actually useful for my case? How many repeats are in there, etc. So there's a lot of that on work package 4. The deliverable is due in 2 months, and counting 84 pages and plus. So again, lots of material there. Then modeling the safety solutions is on simulation structure. The main result now is that we describe a simulation structure for pre-crash and in-crash, and all the models that you use in there in one graphical picture, so that if you use the same layout, it's easy to compare simulation structures between studies. Good. The framework. This is the scope of the framework. And so this is in the draft. So there's some generic things on definitions, user types, some examples will come, and how to formulate a conclusion. The main stages in here are really preparing the assessment, doing it, and then analyzing it. And as you see, there are large blocks here. Now, it seems like it's easy to write this down, but there's actually an awful lot of discussion underneath of them, and a lot of underlying methodology to actually perform this. So that's where the framework is. We also look at cost-benefit analysis, so called economical cost-benefit analysis. So that's also included. Good. Just to give you an example, one of the stages in the beginning, so it's here at the left, the bright green one, define evaluation scope. So there are several check questions here. What is your scope involving? So is it a safety solution, or do you want to look at several scenarios for the same safety solution? Or do you want to compare safety solutions? Do you want to look at the representativeness of what you're doing, or do you have specific metrics that you really want to apply your KPIs for this specific assessment? So those are the kind of questions that you will get. So here there's an interesting one. Do you need to evaluate false positive activation of your system? So that might really change the nature of your study. And true negatives, for example, do you need to evaluate them as well? Now, all of these scoping questions define on how you continue later in the process. The next thing is on the baseline. Essentially, you first need, of course, to know what you're doing this for, so you need to know your evaluation scope. But then you can start looking on baseline approaches. And the simplest would be, I've seen these accidents on these crossings, let's reproduce them in simulation and see if I change anything, how it improves. It's one-to-one copying from accident cases to simulation cases. Well, that's called baseline approach A, okay, but there is more, and there are more options there. Typically, this choice of baseline approach is you would like to do an ideal baseline approach, but then the models may not be available or the data may not be available. So there's quite a bit of hands and forth looking for data, looking for models, and deciding what baseline approach can I really realize and what compromises are acceptable. So that's an interplay that's really important and crucial in setting up your study. And then you can continue to actually setting up the simulation and running it. So here is a picture from these baseline approaches. I'm not going to explain all of it. So this is the one-to-one that I mentioned. Here you generalize from these, for example, accident examples, and you interpolate, make some interpolations and choose all kind of parameters, values in between as well, or maybe extend them a little bit. Here in baseline approach C, as first what you do is create a distribution of what you have observed. So essentially parameter distributions describing accidents or risky situations. And then you sample from that to say, okay, these samples then cover the distribution good enough to actually compare to. Yep. Thanks. I'm going to speed up a bit, and then there is another layer in there which I'm not going to explain now. Just to give you an example of these models, there's a model that we're working on forward collision warning, and how does a human respond to that? And essentially, it looks at we work on both pre-simulation and in-simulation models. This model, what it looks at is response time of the human to a warning, then the response time of a vehicle, time to brake onset, and the time for the vehicle to actually do the braking. So some mathematics in here. This model we have described in detail, and we intend to publish this, so make it available for everybody who wants to use it. Good. If we talk about the impact of FIFA safety, so we include also infrastructure and policy-based measures. So that's really different. Then we work on comparability of these studies. So having a common language to describe with the framework, explicit baseline choices, and also a common documentation format. So we look at the future saying, okay, we give methods for projection over time and region. And then we work on reduced uncertainty. Of course, there's always a stack of assumptions and model decisions in such a simulation, but we will create guidelines to reduce uncertainty and bias. And there will be remaining uncertainty, but then you need to be clear about that and see where the source is. So for the simulation structure, we have this standardized visualization. So that's one way to handle the complexity, but of course there is more. And in the end, this should also go to standardization. So in our stakeholder group, there's already ASAM and some other groups. That was it. Thank you. If you have further questions, you have the name in view.
Thank you very much. Thank you very much, Ciuca. And thank you also for keeping the time and for making reference to the fact that several of these documents and project results are already available on your website. They will become more and more numerous and available on the website and on the Cordis database as soon as the projects go on with their work. Talking about projects who go on with the work, I will now give the floor to our next speaker, Núria Pereira, who is coming from IDIADA. She is an innovation manager at Chassis Active Safety and Durability Division of IDIADA. And she will present us a close project with plenty of results. So, Núria, the floor is yours.
Thank you very much. Okay. Good afternoon. I'm Núria Pereira, as Anka explained, and I'm going to present you the SafeUp. The SafeUp project ended last year in May. We started in 2020 in the middle of the pandemic area. So it was fun times working online with all the consortium. And we had a budget almost of 8 million, and we were 19 partners, a really good mix between research and industry. Yeah. So our main objectives were 5. As we are focusing in safety, we had the analysis and identification on future scenarios. We wanted to develop a platform that was traffic simulation with a traffic mixed, including all the usual ROP members, and focusing on use cases that were urban and not urban. Then we have another objective, focusing in passive safety, to develop monitoring, occupant monitoring, and adaptable restraint systems that were lead to a demo 1, a vehicle, and then finding new sitting positions. The objective number 3 was related to active safety. There were 3 vehicles, one focused in bad weather conditions, another one focused in avoiding critical situations and scenarios, and the last one related to communications between the road, the vehicle, and the vulnerable road users. As well, another objective that we had, it was to develop assessment methodology which mixed of the virtual assessment and the physical tools that we used to test all the developments in the project. And then from that to obtain the impact assessment. And as well, we had another objective to raise awareness about this new situation on the road and in the cities, and explain to users that are not well with knowledge, as technical knowledge that as we have, the new situation that we will face in cities and roads. So a little bit in depth, in Work Package 2 was focused in obtaining safety critical scenarios. You can see here the simulation platform that we developed. We developed models, EKA for the bike model and the pedestrian model. These models were developed using volunteers, so they are real models capturing the real movements of the pedestrian and bike. Then from IDIADA was a real model of an autonomous vehicle. And then the driver behavior model developed for CINEA as well was real, and then UNIFI used volunteers to take the real model for the motorcycles. So all of these models were included and integrated in the IMSU Next platform. We had some challenges integrating all these models because they were developed in different platforms as well. And we had as well challenges in the computer processment of these models. We need a great amount of power to get all those realistic models inside the platform and to be all that processed. At the end, we found all the solutions for that challenges, and we obtained a little bit of results. As well, we saw that we needed more time to even get better solutions, because when we started doing loops of improvement, it was a never-ending process. So still we will be doing loops on these simulations. So yes, it was a lot of work to do and develop this platform, but still some pending work to work and do research on this area. In Work Package 3, we focus in active safety systems. We have 3 vehicles. The first one focuses in bad weather conditions. You can see here pictures from Ingolstadt laboratory with fog and rain, and how the sensors detected the pedestrians with obstacles in front or without it. And yeah, we did several tests in this facility. Then as well, below, a vehicle from Bosch that was for developing the steering emergency system, combined with the brake emergency system, combined, so it had to decide the vehicle with obstructions in it when the vulnerable road user crossed the scenario, if it had the moment to activate the emergency braking system, or it was a moment to steer the steering wheel and avoid the pedestrian or cyclist. Then IDIADA with Toyota, they developed also with a third system of communications between the infrastructure, the vehicle, and the pedestrians and bicyclists. And it was the same. The vehicle received signals from the roadside unit to give information that was facing a critical scenario, and as well at the same time the pedestrian got a warning on the same situation. Okay, sorry. Yeah, and Work Package 4, it was focused in passive safety. We were developing as well restraint systems and occupant monitoring system. You can see here the video, which I don't know if it's working well. It's inside the vehicle, and you can see how the volunteers were inside the vehicle, and the cameras were capturing the movement of the person inside the vehicle. As well, if it was so close to the steering wheel, the range of motion, and was like doing awareness that the person in there was too close to the airbag area. As well, the adaptive restraint system that was developed was included in this demo car, and further on you will be able to see a little bit more on this on a video, and well, to see that the cameras were detecting the movements of the occupant. Then as well, the Work Package 4 work with use cases inside the occupant's positions for L4 vehicles. A lot of literature review was to design the sitting positions as well from other projects as Oscar. And you can see below there was development of human body models with adaptable restraint system and people recline inside the vehicle. It was developed in human body models, and then in the testing facilities of IDIADA, we developed a sitting position recline with a Thor recline as well to do the tests and do the correlation between the human body models and physical testings, and prove the adaptable restraint system that was developed in the project. As well, here faced some challenges because there was only one Thor that it reclined, and it has to travel a lot around Europe. And then the same happened with the sitting position with this sled test that we had to develop as well, because there are few in Europe. So yeah. Okay, regarding Work Package 5, we here worked in the assessment methodologies. Yeah, we developed a methodology from information regarding obtained from peers and prospect projects, and some of it went to the Before Safety project as well as input. And in here, we try to assess the methodology combining all the physical testing developed in the project with all the simulations that were to correlate. This testing was approved as well in the simulations, and get the impact assessment of these simulations as a little bit of before safety work. So we were before that project, so now we should be able to get more results on this. But yeah, the main results were that it was an avoidance of critical injuries. If we combine it, demo 3 and demo 4, demo 3 was the steering wheel, and demo 4 the one from connectivity. The avoidance of critical injuries was reduced 60% from 8%. And then as well, if you combine it, the restraint systems developing safe up with the emergency braking was a reduction of critical injuries of the 60%. As well, in demo 2, which was assessing the effect of rain in the sensors. And in demo 4, it was seen that the connectivity between the infrastructure, the vehicle, and the pedestrians, and has a high potential in avoiding crashes in situations on there is some little time to react, and of course there's obstruction. The last work package that we had, and not the least, it was regarding training activities and knowledge transfer. We developed infographics, presentations, e-learning courses that are available in different languages. All of these videos and material is available on the website, on the Knowledge Center. It will be there for quite a long time. So if anyone is interested in obtaining this information, there it's available with all the deliverables as well. Just in case that you want more information, you can contact us. But yeah, really aiming to everyone to get in here and learn a little bit of the videos and any learning courses that we have. So the lessons learned that we got in this project, it was that emergency braking systems with a reclined position were decreasing the injury risks. To remember that the emergency braking system is the more effective safety feature that we have, and that really gets most of the scenarios that it was developed for, and it's really important, this system. The steering system, it's really good for late detection collisions, but as well needs a little more of research. The vehicle to infrastructure, it's important in high speeds and close obstructions. And as well, it helps to obtain more of the field view of the systems. As well, there we need more research in the side impacts of the vehicles when do the steering wheel. And for the bad weather conditions, we were focusing on sensors, and as well, we need more work done bad weather conditions. For the models that we develop require more attention and more research. In model human driving, riding, and pedestrians, we need there more research. And as well, if we want to do all these simulations, we need more data. Data is crucial, and we need data for traffic data, trajectories, infrastructure maps, and accident data to keep working in simulations. And then as well, the methodology that we developed in the project to do this system platform for safety critical needed more investment and more research. And the impacts of the project, as we were focusing in road safety, then we can say that we made progress. We developed systems that improve the safety, and we were searching for solutions to get this road safety in better expanding ways. The methodology need to be redefined. But we worked in several assessment methodologies. Then the outcomes improve the road safety in general. And of course, more research and development is required in these areas. As well, in order to get all this technology that we developed, stakeholders are crucial to be involved in a ways to get more exploitation and commercialization of these systems. And in general, yeah, the project made an effort to work and contribute in the road safety and for future efforts in this area. And finally, I will play a video of the final events.
The SAFA project is an European project that started in June 2020 and it's finishing this May 2023. We are here celebrating the final event. The main outputs of the project are the demo cars that we have developed.
It was an interesting part of the video. I don't know why it's going.
Checklist specific.
The other has participated with the vehicle side, with the perception and ADAS systems, and V2X in that vehicle. Sirth has developed the V2X communications in the VRU side with pedestrian and cyclist special devices, and Toyota has provided the vehicle for this demo.
As well, the project has obtained results in traffic safety, developing models for getting safety critical scenarios for the near future with traffic mix.
It worked. Well, you have the video online if you want to see it in a normal piece.
Thank you very much, Nuria. So that was from our side. Now we would like to listen from you and from our co-moderator. So Peter, I let you introduce the next part and manage the questions.
Yeah, if it's okay, I will stand here and have a better overview. Well, we're talking about greening and global competitiveness in the automotive industry very often these days. And yeah, we tend to forget, as you said, that there are still about 60 to 70 road fatalities per day. So still a long way to go for Vision Zero, that political vision, meaning that we should have a road transport system in which nobody is killed or severely injured anymore. And I think that session today has given us a nice overview of different areas of road safety research, starting from collision avoidance, then via protective safety, but also including the safety assessment methods that are further developed, and not ending with raising awareness of road safety needs. I think also the ambition that we have seen here of having lighter and smarter structures in our future vehicles, be able to predictively evaluate what new systems will be able to perform or to deliver, and also the avoidance of vulnerable road user crashes to an even higher extent than we can achieve that today. That's all very encouraging. And you even extend it towards automation with new seating positions in more or less highly automated vehicles that we may see in future. So I think that's good results and good projects that are still delivering results that we've seen. I'm still quite convinced that some questions have remained open, and would be happy if some of you would like to ask the questions here in the auditorium. And there's one, Jörg.
Yeah, good afternoon. Thank you very much for the nice presentations. My name is Ciuca. I work for Toyota Motor Europe. I have a question to Ake. Very interesting topic, very good combination of different methods. But my question is regarding the complexity. Did you have in your project also somebody who is very deeply involved in production engineering? In particular, how to produce that, because you have combined very complex methods. This is an optimization which looks very nice in the way it is, But does it really work in real life? Is something which, can you maybe shed a light? Did you have somebody who would be able to produce it and who's a professional on telling, yes, we can produce it?
I understand your question. I'm sorry. Now, yeah, I understand your question. We can make two different parts. From one part, when we are talking about new parts of the front-end structure, new parts, the crash box, the struts, or well, the different parts we are able to produce. We have several partners that they are experts in aluminum processes and also the thermoplastic with carbon fiber reinforced. So in this case, yes. We are talking about a real product. We can say that it's a real design that is, we are sure that it's manufacturability, we can say. But when we talk of the other active systems that we talk about, to be able to change the geometry of the bumper, or we are able to change the rigidity of the strut, or we are able to change the way where the energy crash is going. In this case, we are talking about, we can say, ideas that we are going to validate at a virtual level. But it's true that in SALIENT project we are not able, with the time and the money we have, we are not able to be sure that we can integrate in the real cars. So we have two different approaches, we can say. One, yes, it's real, we can product. And the other, there are concept ideas that we are going to validate, but at virtual level, at simulation level.
Okay, thank you. Maybe a question from my side related to that. You explained about the need for eco-design and recyclability. And then you showed solutions which are going for, well, multi-material design, use of fiber-reinforced plastics, which is maybe not the most logical choice at first sight. So could you comment a little bit on how that fits together?
Yeah, it's true that I explained before, multi-material is the best solution for performance, we can say, but sometimes it's not the best solution because later we have to disassembly, we have to separate, and we have to reuse these parts or recycle these parts. So yes, it's not easy, but it's true that we are using also results from other previous projects. For example, ALMA, that tomorrow we will talk about this. They have work in, for example, different joining technologies that using adhesives that at the end of the life with an external stimulus you are able to separate. So it's one option to go to have different materials inside, and 10 years later when the vehicle is end his work, we can separate. It's one option. Aluminium, well, if we talk about aluminium, it's recyclable, we can say. And there are other results also from other projects to be able to separate thermoplastic and carbon fiber material. So, well, it's not the global solution we want, but it's true that we keep in mind and we point different solutions to be sure that this is the best option in terms of environmental impact.
Okay. Yeah, I mean, understand it's also a research project and not product development at the moment. Yeah, thank you. Magnus.
Yes, Magnus Granström, Safe Chalmers. A question to Nuria. And I could have asked this to my colleagues from Chalmers or Otley, but I haven't, so I thought I'd take the opportunity here. Because you're looking into the vulnerable road users or unprotected road users and bad weather condition, which is a full project or more in itself, right? And you just touched on it in the presentation. Did you find any specific things that you can see, okay, this is something we can implement more or less now? And the second part is sort of what are the main next steps?
On the project, they were only focused in the detection of the pedestrian and cyclist, so how it affected the rain and fog on the sensors. So there is available with results available, but they only assessing how was the effect on different rain flow and fog, and only on that. And then the further steps are on seeing how we can improve this detection in those bad weather conditions, and yeah, how this more in scenarios that are more like area NCAP related, how that can be implemented. But at the moment, the project only focused in how the sensors were affected with those phenomena. But yeah, a lot of research can be done in that area. Yeah.
Okay, you know that. Okay, Magnus, you have another question? Feel free.
Yes. So you were looking around in the room, right? And no other hands. So maybe a question both to Nuria and Ciuca. Back to the vulnerable road user topic, and have you specifically looked at children? Sort of detecting, because sometimes it's just as anyone else, but sometimes they move differently, and of course the size is different. Is that a use case that you have been looking into?
It's not a use case that's included now in our use cases. I do agree it's an important use case in all kind of urban situations. Everybody knows the nightmare scenario with the ball rolling onto the street. If we talk about the framework, it is included. So if your evaluation scope is looking at children, say near a playground or near a school as a situation, then it is included. But then the question becomes, do I have data about children in the current situation? Do I have human body models for children? Yes, they are there. Do I have behavior models for children? They are probably not there, and not as reproducible as some human adults. So the framework, yes, it can cover it, but I should be honest, on data and models, there's an awful lot missing. Yeah.
Yeah, in our project we focus more in the adult pedestrian and cyclists, because for perception we had some issues there, so it was easy to detect, because obstruction and going out, it was easier to detect. But yeah, as more work is needed in this area, yeah, for sure can be assessed to work on that. As well, we work in the protocols of EuroNCAP, trying to put a little bit different, more strict than EuroNCAP to see if those cases were detected, but only using dummies of adults.
Yeah, indeed, you cannot do everything in just one project. Therefore, that cooperation between different projects is quite beneficial sometimes. I think you all mentioned that you are also looking at it or have been making use of such cooperation. Maybe you even noticed some new opportunities today or yesterday on other projects that you could talk to. Could you comment a little bit more on that? What went well, what didn't went so well maybe, and where you see future potential? Maybe even for improvement from a program point of view?
Well, in our case, we're of course halfway down the project, so we hope to still use some of these opportunities. There's one where, of course, there's a Sunrise project working on safety assessment, which is a bit more vehicle-centric than V4Safety, and also looking a bit more to type approval and really proving the safety of a system under test. But there is a lot of similarity and connected areas there, so reusing things there. The training element that you mentioned might actually be quite interesting for V4Safety as well, because we will come with an instruction for the framework, but then you need to test the instruction as well, and you need to hand it over to the potential users. So training might be a very interesting way. So those are the kind of handovers I'm thinking of. Yeah.
Okay.
Yeah.
So also linking then the projects in the regular call, so to say, to the
Yep.
Ciuca partnership, for example,
Yep.
which is also a good link, of course.
Yep.
Any other comments, Nuya?
Yeah, well, from my side is there is more work needed in the development of simulation models for safety critical scenarios. The aim was to be able to detect safety critical scenarios with autonomous vehicle before having accident data, because we cannot allow to have accident data in order to act and develop systems. And it was really ambitious, those activities, and it was like, could have been a full project itself. But I think the idea that we tried to develop there was really good, and there is more need to work on that area for sure. And the systems that we developed all need more fine-tuning to be able to get out on the market. But I'm sure that everyone is keeping activities in further projects to develop those systems.
Okay, thank you. I think, Xavier, there was a question over there. Oh, two questions. The right-hand side gentleman was first.
Okay, thanks. Thanks for all our presentations. Sébastien Pirer, coming from Michelin. I have a question for, I think, all of you. As Raquel said, there is a lot of difference in shape and size of vehicle coming in the market today. And if we look at the current state of crash scenarios, do we see trends in which this big EV vehicles versus new exotic shape, like last mile delivery, for example, vehicle, come in as a very critical element for critical accident? And do you think that somewhere in the years to come, there might be some new regulation dealing with how to handle this different shape, size, and weight of vehicle?
I missed the first part of the question.
The first part of the question was, do we see trend in the crash scenarios that are critical due to the bigger vehicles coming in urban/suburban or whatever crash scenarios?
Yeah. Well, from the point of view of the vehicle structure, I have to say yes. I have here the data. If we compare in a crash, in a frontal crash, if we compare the fatalities for the occupants between a small car and a small passenger car and a SUV, the difference is 7.6. is really important. So we are a factor, yeah, 7.6 higher for a SUV than for a small car. So when we are talking about electric vehicles. So the size is not also higher, but the weight, yes. So at the end, I think it's critical, and it's critical also because in general, not all the OEMs, but in general, the development of the electric vehicles is to transform the IC vehicles into electric vehicles. I mean, there are not a white paper and I start thinking in a new car, because the electric vehicle is different, a new car. The weight of the is different. The motor is not in the same position, so it's fully different. And in general, the strategy is to modify the IC model to transform in an electric model. Not in all cases, I repeat, but it means that in some cases we are not dealing the big problem in the way that we have to act. So for me, it's my personal opinion, I think yes, it's real. I'm not sure if it's critical, but it's clear that there are a big challenge in this point.
So I have nothing to add to that. I have an opinion, but Raquel has the facts, so thanks.
Yeah, that's always a good strategy. Not to say too much if you just have an opinion. But okay, there was another question in the back of the room.
Ellen Marshall, Innovate UK. So, Transport for London's direct vision standard for HGVs, do you see that being replicated across other cities in Europe?
Is that a question to a particular panelist?
Just to anyone.
Anyone who would like to respond? Could you maybe repeat again? I think.
Okay. So TfL, Transport for London's direct vision standard for HGVs, which has been put into force next year. Do you think that's setting a precedent for other cities to do the same thing? So the HGVs won't be allowed to go into London without having this safety standard for vision.
So it's a standard for heavy goods, vehicles?
HGVs or HDVs, I suppose.
And it would limit the accessibility of the city centre, I guess.
So it's for the vehicles themselves. It's about like view, like being able to see children and stuff like that. So yeah, it would stop the vehicles going into London. But do you think that's like a precedent that's going to happen throughout Europe, or do you think it's just a sort of one-off?
So what I understand from your question, in London, the policy now is to ban or reduce the amount of heavy vehicles. So, no?
Yeah, it's about the equipment, I think, or the design. Yeah.
No, it's the design of the
Magnus,
vehicles.
maybe you could explain a bit.
Yes. Is it okay without the mic? Yes. So basically, it's I'm not sure if I can answer completely, but I can comment on the question at least, and because it's very much about the visibility, right? So as a truck driver, you should be able to see a bicyclist, and and London then enforces regulations on how this visibility should be. You have to have more windows on, well, depending on which side of the road you drive, left-hand or right-hand windows. I know that Copenhagen is looking into this, and also coming from Gothenburg, I know that they have had a look at it, especially also related to construction traffic and so on. So it's a valid point. I think it'll be very interesting to follow and see, okay, how will this influence the flow of larger vehicles? What kind of impact will it have on the accessibility, but also, of course, on the accidents, especially with bicyclists and pedestrians? Then.
There's also cameras now. Heavy duty vehicles.
Yeah, so a combination of cameras, windows, and short-range radars as well. So there are sort of different ways of doing it. But it's, I think quite a lot of cities are following and seeing what will happen with this initiative from London.
Thanks.
Yeah, thank you very much, Magnus, for stepping in. Would you like to add something?
Yeah,
anything, Ditzo?
Of course, from Free for Safety perspective, I could have a view on this, but that's, I guess, the typical approach would be to say, okay, if we model this, what are the factors that we need to model and are actually improved because of this policy? And then one of the factors that comes in is the predictability of a traffic situation. So typically in construction, there are all kind of cones, the roads get narrower, it's harder to oversee, there might be temporary traffic lights. So you will see that back in driver response or response times to doing the correct action. It might be the same for a cyclist trying to squeeze into a very narrow lane where he's not supposed to be. And so so essentially, if we want to model this, then we need to also look at changed human behavior in construction zones. And it's not easy, but actually doing the construction site monitoring with a high positioned camera, you could actually collect that data and model it. So it's an indirect answer. I guess we need the models. Yeah.
And possibility for further research. But Jack, you would like to add something?
So you covered the questions? already?
Well, would you like to respond, or do we have another question?
I would have another question.
Yeah, please go.
Okay, so because I think you were starting the round with what is missing, and to be honest, I found it between the lines of what Ciuca was presenting, but also what Nuria was presenting. We are looking into new scenarios. We are looking into new, unexplored ways of transportation. What we are totally missing yet is the behavioral aspect of most of that, because we are setting all these new systems onto our customers, onto our population, and in many areas we just don't know how they are going to react. If they are going to like it, how they will activate, deactivate, shut them off, which is the worst, of course, after all investment, all the super great ideas of safety engineers. And that is where I think we have by far not yet done enough. And regulation is pushing us to implement them. Euro NCAP is pushing us to implement politics, policies. They are all going in the same direction, but we're missing this part very much. And I can see only one project coming up that has it.
Okay, yeah, thanks for that comment. You know, I will also be the poor guy who will have to write a report on that session in the end. And well, I'm not super. It's a nice session, but still a duty that I have to fulfill. And I shall also report a little bit on the impacts of projects. I have noticed that you have made a nice, well, I don't know, is it a calculation or estimation of expected impacts from your project, Salient? It would be nice to understand a little bit more what is behind that, and then maybe also the others could comment a little bit more on the longer term impacts that you expect. I think we are usually trying to measure them in number of fatalities and injuries saved if you look at the work programs. And you did some, at least, estimation on that.
Yeah, for the moment is the estimation. Sorry. For the moment is the estimation we have at this moment. We estimate to have a reduction about 48–50% in weight reduction in the front end structure. So at the end, it means around 10% in the body, in the full body, in the body in white. This is in terms of weight reduction. Then we talk also in terms of environmental impact, directly by this weight reduction, obviously, but also due to the process manufacturing. And the most important, the impact in terms of safety. So if we have estimated that if our technologies or our strategies are adopted by around 10% of the total global production, it's very much, we know, but it's an estimation. If 10% of the cars in the future adopted these solutions, around 2% of we are going to have around 2% of improvement in fatalities and injuries in the passengers. This is not too much. It's true, but there are 2 points, only thinking from the point of view of the structure. So then all the improvements from the point of view of road safety, to be able to predict the crash, etc., will help, obviously. But for the moment, estimations. I hope that next year I can be here telling you that we have reached these numbers.
Okay, well, I think, thank you very much. We for Safety in the end will help people to estimate the impacts of their developments and research. Still, would you like to add anything? Otherwise, maybe Nuria, you could also comment a little bit on that.
Yeah, so we want to make, well, simulation is here to stay, and we will use it to set our policies on what is the best direction to reduce casualties in traffic. And what you see already is that pedestrians and cyclists are actually the rising numbers, and the vehicle occupants are actually not even the rising numbers anymore. In the Netherlands, there is more casualties and on cycles than in cars. So making sure that you can actually reliably do something with simulation, that's what should be the main impact of V4 Safety.
Yeah, on the impacts of SafeHub, we did a calculation that the optimistic calculation that a car with all the safety systems that we developed in the project had it in it and was on the road. I cannot remember the percentages of implementation of those systems were in the market. It was a reduction of the 60% of fatalities, but that was the optimistic view. And then with the 10% of reductions of fatalities was with the implementation of the communication between infrastructure, vehicle and pedestrians.
Yeah, thank you very much. That's good numbers, and maybe I should look them up in your reports then. It's the second time, by the way, that your project is presented here. So in the RTR conference, I mean. So it's completed now. Logical question, what's next? I mean, how do you make sure that things will
I'm
find some
aware
take-up?
that some projects that were accepted in September had some information regarding the training that we developed in it. And well, V4 Safety has some of the work done in it. And well, at the moment, I know that some of the work it's spreading in other projects.
Okay, that's good. Anyway, thank you. Okay, I think we are also approaching the end of our session. So I would like to remind you that at 4:15, the next session will continue. Until then, you have a coffee break now. I think in front of the Einstein room downstairs. I have not asked for future research needs, and there's a good reason why, because if you have your coffee now in the area in front of the Einstein room, also have a look at the AirTrack booth, because there you can grab, for example, that nice leaflet here, in which you will find a summary of future research needs, and also look at the AirTrack website, because since December last year, there is also a paper available there summarizing some of the well, short-term research needs that we see there in the AirTrack Safety Working Group. Little promotional break I had to make, for sure. And finally, for tomorrow, those who are very much interested in road safety research, and I guess most of you are, of course, there's the CCAM sessions that might be of interest for you as well. And then there's also a session tomorrow morning on human factors in transport safety that might be interesting in the context of road safety research too. So, well, would be happy to see you there again. Thank you.